All right, so here is our video for filling out a reference page. What this reference page is going to be used for is where we go anytime we're trying to prove triangles congruent. So we're going to pull this page out whenever we're working in our proofs book. This is a way for us to summarize all the information that we've learned this week so we don't brain dump it over the weekend. So the first way that we learned to prove triangles congruent was by the side congruence postulate. It said if 3 pairs of sides in one triangle are congruent to 3 sides in another triangle, then the 2 triangles are congruent. What those would look like is that all 3 pairs of sides would have tick marks on them. So we mark sides congruent with tick marks. The next one that we learned is that if 2 sides and an included angle of one triangle, says 2 sides and an included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. Don't forget that it needs to be the included angle. That is the angle between. After we learned side, and side, angle, side, the next day we learned angle, side, angle. It said if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the 2 triangles are congruent. Remember, included means between. So, an included angle is included between 2 sides. An included side is included between 2 angles. The fourth shortcut that we learned is that if 2 angles and a non-included side of one triangle are congruent to 2 angles and a non-included side of another triangle, then the 2 triangles are congruent. So, 2 angles and a side opposite them. So, if you pick one of the angles, the side opposite to either angle would be a non-included side. The last shortcut that we learned to prove triangles congruent is the hypotenuse leg congruence theorem. If the hypotenuse and leg of a right triangle, so that is the hypotenuse and leg of one right triangle, are congruent to the hypotenuse and leg of another right triangle, then the 2 triangles are congruent. So we learned all of these properties and then we practiced some proofs. And there are some proofs in our notes. One thing that we've talked about is how when you're doing a proof, your reasons can be definitions, postulates, properties, and theorems. So here you have a quick reference guide for reasons that sides are congruent. Well, an obvious reason that sides are congruent could be that it's given to you in a proof. Another reason that sides can be congruent is by definition of midpoint, because a midpoint splits a segment into two congruent segments. And remember, sides are segments. Another reason sides can be congruent is because there's a reflexive side, or a shared side amongst two triangles. Side is congruent to itself. Now, there are a lot of reasons that angles can be congruent. The most popular one that you'll see is vertical angles. Vertical angles, remember, they look like this. Anytime two straight lines or segments cross each other, a pair of vertical angles, two pairs of vertical angles are created. Now, other reasons that angles can be congruent, well, alternate interior angles, alternate exterior angles, and corresponding angles are all angle pairs that we know to be congruent. We can only say that those angles are congruent if we have parallel lines. You must have parallel lines to use any one of these three reasons. Now, another popular reason that angles are congruent is by definition of an angle bisector, because an angle bisector splits an angle into two congruent angles. So this reference page you should have out anytime you're working in your proofs book. We're going to work in our proofs book several times in the next coming week. Now, the last thing that we're going to talk about is CPCTC. This is a preview for what we're going to go more in depth on next week, so please pay attention. This part is important. It's the trailer for next week. CPCTC stands for corresponding parts of congruent triangles are congruent. This we know to be true. Corresponding parts, so that means the corresponding angles and the corresponding sides. If the triangles are congruent, then those corresponding parts are congruent. So here, if triangle ABC is congruent to triangle DEF, then its corresponding angles are congruent. Let's look at which ones correspond. Well, angle A would correspond with angle D. So if triangle ABC is congruent to triangle DEF, then angle A is congruent to angle D. And angle B would be congruent to angle E. And angle C would be congruent to angle F. Those are the corresponding angles. And if our triangles are congruent, then our corresponding sides would be congruent. So parts can be angles or they can be sides. The sides that correspond with each other would be AB would be congruent to DE. And BC would be congruent to EF. And lastly, CA would be congruent to FD. This makes sense because we understand what corresponding figures are. Corresponding triangles, we understand what congruent figures are. Congruent triangles and congruent figures have corresponding angles that are congruent and corresponding sides that are congruent. Now, this is a reference page for proofs. So, when will we be using CPCTC? We can only use this as a reason a reason parts are congruent. And so remember, parts are sides or angles. Now we use CPCTC. We use it after we've proven two triangles to be congruent. So we can't say angle B is congruent to angle E. We can't say any of our parts are congruent until we know that the triangles as a whole are congruent. So use CPCTC after proving triangles congruent. If that doesn't make a whole lot of sense to you right now, that is A-okay. We are going to get more in depth with this on Monday. So come ready to get some clarity. Have a great weekend. I'll see you on Monday. Peace out.